Imagine you compress the entire age of Earth into a single calendar year. January 1st, the planet just formed. December 31st, midnight, right now. Here's the question. When do you think the first human shows up? Maybe November? October? No. Homo sapiens appears on December 29th. In the evening, 2 days before the end. All of written human history, the Egyptian pyramids, Rome, the Middle Ages, the Industrial Revolution, the Internet, that's the last 18 seconds of December 31st. 18 seconds out of 365 days. And you think you understand what a long time ago means? You don't. None of us do. But today we're going to try. Hey, if you're new here, this is where we take things that sound like a textbook and break them down until they start causing genuine existential discomfort. Subscribe because it only gets worse from here. So how old is Earth? 4,570,000,000 years. That number is everywhere. Wikipedia, textbooks, pop science. We read it and move on because our brains process 4.5 billion, roughly the same way they process a really, really long time. There's no felt difference between 1 billion and 4 billion. They're just big numbers, and big numbers are a dead zone for human perception. So let's stop talking about billions. Let's talk about what those billions actually mean. Here's the first thing to understand. When scientists say Earth is 4.5 billion years old, they mean that almost all of that history happened without witnesses, completely without witnesses. There was no one to look around and say, oh, interesting. Microbes appeared roughly 500 million years after the planet formed, and even they don't count. Complex multicellular life is only the last quarter of Earth's history. And vertebrates, animals with bones and a nervous system, anything like ours, have existed for less than 12% of the total time the planet has been around. 12%. The rest is a planet that existed entirely for itself. Moving tectonic plates, boiling with volcanoes, freezing over, thawing, and nobody was watching. Honestly, that's a little unsettling. But here's what's interesting. How do we even know how old Earth is? It's not an intuitive thing. You can't just look at a planet and say, yeah, it looks about 4 billion. People spent a very long time trying to figure this out, and a very long time getting it wrong. In the 17th century, Irish Archbishop James Ussher calculated Earth's age from biblical genealogies and landed on an answer, 4004 BC. So Earth, by his reckoning, was just over 6,000 years old. And he wasn't a fool. He did the most thorough analysis possible with the tools he had. The tools just happened to be, to put it gently, the wrong ones. Then in the 19th century, William Thomson, Lord Kelvin, the same one the temperature scale is named after, calculated Earth's age based on how fast a molten ball would cool. He got somewhere between 20 and 400 million years. Better, but still off by an enormous margin. Why did he get it wrong? Because he didn't know about radioactivity. Earth isn't just cooling, it's generating heat internally through the decay of radioactive elements in the mantle and crust. Kelvin couldn't have known that because radioactivity wasn't discovered until 1896. And this is where the real detective story begins, because radioactivity is exactly what gave us the answer. Radiometric dating is essentially a clock built into every atom. Some elements are unstable. They decay at a predictable rate, regardless of temperature, pressure, or chemical environment. They just decay, full stop. Uranium-238 transforms into lead-206 with a half-life of 4.5 billion years, which means that if you have a piece of rock and you measure how much uranium is in it versus how much lead, you can mathematically calculate when that rock formed. It sounds simple, but there were decades of work behind making sure the method was reliable. Scientists tested it on samples whose ages were already known from other sources. They ran multiple dating methods simultaneously on the same samples. The method held up. And here's what those methods showed. The oldest Earth rocks ever found in Canada, the Acasta Gneiss Formation, come in at 4 billion and 2 million years old. But Earth is older than those rocks because when the planet was first forming, the surface was molten. There were no solid rocks yet. To pin down the actual age of the planet, scientists dated meteorites, the ones that form from the same solar nebula as Earth. And there, the number got sharper. 4,570,000,000 years. Give or take 50 million, but even that margin of error is larger than the entire span of complex animal life on this planet. Okay, let's pause for a second, because I want you to feel the scale, not just read the numbers. If you took all of Earth's history and stretched it across a standard roll of toilet paper, about 50 meters, the first traces of microbial life would appear around the 6th meter. Dinosaurs wouldn't show up until the 47th meter. And humanity, all of our development, culture, technology, art, would take up less than the last millimeter, literally. Less than 1 millimeter out of 50 meters. If you're trying to picture that right now and it's not working, that's fine. The human brain did not evolve to intuitively grasp geological time. We understand yesterday, a year ago, 100 years ago, that's old. Billions, that's past the edge of what we can actually feel. But here's where it gets genuinely interesting. Let's talk about what came before us. Not before humans, before complex life entirely. Because most people think of ancient Earth as dinosaurs. But dinosaurs are recent. Dinosaurs ruled from roughly 205 to 66 million years ago. They went extinct 66 million years ago. Earth existed before them for another 4 billion years. 4 billion years, no dinosaurs, no land vertebrates at all for a long, long time. The first traces of microbial life, stromatolites, layered structures built by cyanobacteria, date back roughly 3.5 billion years. This isn't a metaphor. There are actual fossils in Australia, the Pilbara Formation, dated to exactly that age. Almost 4 billion years ago, something alive left a mark in rock. And that mark still exists. You can go see it in a museum that's simultaneously mundane and completely unbearable in terms of scale. And between those first microbes and the first complex animals, there's another 3 billion years. 3 billion years of bacteria, nothing but bacteria. Earth kept going, oceans boiled and froze, volcanoes erupted, continents drifted, and the only living things on the planet were microorganisms. The planet was in no rush. And this is the part that personally stops me every single time I think about it. About 2.5 billion years ago, something happened called the Great Oxidation Event. Cyanobacteria, the same ones building stromatolites, figured out photosynthesis. They started producing oxygen, and that oxygen, for most of the microbial life on Earth at that time, was poison. Literally poison. Think about that. The biggest ecological catastrophe in Earth's history was caused by organisms breathing out the thing we need to survive. The oxygen that for us means living, it nearly wiped out everything alive at the time. Most anaerobic organisms died off or retreated into niches where there was no oxygen, into sediment, into the guts of other organisms. And the planet was changed forever. Without that catastrophe, no oxygen atmosphere. Without an oxygen atmosphere, no complex multicellular organisms. Without those, no fish, no reptiles, no mammals, no primates, no people. Everything that exists right now grew out of a catastrophe that happened 2.5 billion years ago and played out over tens of millions of years. And nobody understood what was happening. Nobody understood anything because brains didn't exist yet. But let's come back to us, because there's one detail about human time that I personally can never let go of. Homo sapiens, anatomically modern humans, appeared roughly 300,000 years ago. Not 100,000, like people often think. 300. That's the updated number after finds in Morocco in 2017. 300,000 years. And only in the last 5 or 6,000 did we leave behind anything you could call civilization, meaning 98% of our existence, humanity lived without cities, without states, without writing, hunting, gathering, migrating, telling stories around fires. And the earliest record we have of humans fighting each other over territory, the first documented battle, is about 5,000 years ago. The earliest known love letter is from around the same time, Mesopotamia, cuneiform on a clay tablet. Someone felt something for another person and decided to write it down. 5,000 years later, the tablet still exists. That's either a very short time or a very long one, depending on which direction you're looking from. There's a concept I keep coming back to: deep time. It was popularized by geologist John McPhee in his 1981 book, Basin and Range. The idea is simple. There's the time we experience, days, years, generations. And then there's geological time, where even a million years is recent. Both exist in our heads simultaneously, but they almost never actually connect. We know the numbers. We don't feel them. McPhee wrote that if you stretch out your arm and imagine all of Earth's history from your shoulder to your fingertip, one stroke of a nail file erases all of human existence. That's not poetry, that's math. And here's the thing. There's something both strange and oddly calming about it. Earth doesn't know we're here, in any sense. Tectonic plates move at the speed your nails grow, about 3 to 5 centimeters a year. And they do not care that someone is building cities on the surface. The Atlantic Ocean is getting wider. The Himalayas are slowly rising. The Yellowstone caldera is building pressure. All of this is happening at a pace where 1,000 years is nothing and a million years is a normal step. The planet runs on its own rhythm, and that rhythm doesn't require us. But here's where I want to land. And this isn't a cliche, even if it sounds like one. We are the first creatures in 4.5 billion years who have been able to figure this out. The bacteria that lived 3 billion years ago had no idea they were changing the atmosphere. Dinosaurs had no idea they had 100,000 years left. The first mammals had no idea they'd be the ones to survive the asteroid. And we know. We built dating methods, measured isotope decay in meteorites, counted sediment layers, constructed mathematical models of heat flow, and we got a number. 4,570,000,000. And then we took that number and tried to understand it with toilet paper rolls, with calendars, with analogies about nails and nail files. Not because it's useful, but because we simply can't help trying. And if you started this video not thinking about deep time, and now you are, drop a comment and tell me which analogy hit you hardest. The toilet paper roll, the 18 seconds on the cosmic calendar, or the oxygen catastrophe. I'm genuinely curious where it lands for different people. See you